So, my name is John Michailidis, obviously. I'm the head of data engineering in BI in Light and Water, and today we will be discussing about navigating the data engineering spectrum in general under the boom of AI of the last 1 year and a half, 2 years, something like that. What we will see today is, first and foremost, we will understand what exactly data engineering is doing, what a data engineer is doing day to day. We will try to understand the challenges and solutions that AI can provide in the data engineering spectrum. We will dive through a real-world case scenario, which we've been working on with a team for the past 1 year and a half, something like that. And then we will try to make some predictions, probably, about where data engineering is going. Before starting, we should lay the foundations of what data engineering is exactly and why it's so important on today's market. So data engineering essentially is the facilitation of everything, the facilitation of data and pipelines and everything in order to understand, build and deploy the pipelines that everyone is needing, okay? In order to work on data science, data analytics, data engineering, everything. By basic concepts of data engineering, essentially we are diving into the nuts and bolts of what makes the field so essential. And by using data engineering, essentially we are unpacking the fundamental concepts in order to understand how our data are working, what our business is doing, etc. Together, those 2 points, the importance of data engineering and the basic concepts that enables every data-driven business, plays an integral role of the data inside a company, right? So let's start with essentially what a data engineer is doing on a day-to-day basis. First and foremost, data engineering is a very important part of any data-driven company, as stated, because it's the one, sorry about that. It's the one that enables everyone to work with data, to understand the data, to gain access to the data, etc. Business and technical people alike, of course. In the context of AI, data engineering essentially gives us the ability to build robust systems that it will enable any AI-powered data engineering project, task, or whatever to work in the optimal format. The importance of that is highly critical, because if you imagine, for example, ChatGPT, the important thing of ChatGPT is not how the LLM works or how the model, the LLM model, gives back the answer. It's how it can operate for the better part of the last 2 years in that manner, and without having any sort of problem accessing it, etc. This is the data engineering. This is data engineering in the context of AI. Now, regarding the data engineering per se, what he or she is doing on a day-to-day basis, it's he or she is using data infrastructure. He or she is building data infrastructure management systems, databases, data lakes, cloud storage, whatever. They are improving data flows, they are building ETL processes, they are building automations on the data tasks of every pipeline, etc. The influence of data engineering, the influence of AI in data engineering is also a very important task. It addresses the complexity of the neural networks. And when I say about neural networks, I mean the large language model, of course, in the context of AI at least, giving back to the LLM or any neural network high-quality data. Right? For example, feature engineering, or improving of ML models is something that a data engineer should do in order to build the LLM in the most optimal format, etc. High availability and scalability. This is a very important part of building AI-powered, at least, or not powered, AI systems, because in the era we are living currently, building high availability systems and highly scalable systems, it's the most important part, because imagine that, for starters at least, ChatGPT had approximately, in the first week, if I'm not mistaken, 1 million users. In the first month, it had 10 million users. And imagine the system, the engineering system behind and the infrastructure that it needed, ChatGPT needed, in order to be able to support that peak of requests, etc. When we are talking about high availability, the principles, at least, of high availability, scalability, and disaster recovery are very important and critical, crucial in data engineering to ensure that our AI systems are both robust, reliable, etc. High availability guarantees that our data-driven services are consistently accessible, which is something very critical for AI applications. We need high availability systems. We need to be able to support our tasks if they are AI-powered in real time, and consecutively, we need real-time decision-making, which is what AI is for, right? Scalability, on the other hand, ensures that our infrastructure can adapt to the evolving demands of AI workloads, facilitating growth without having performance loss. Yes. As stated before, this is the most important part of AI-powered ecosystems. Challenges and solutions in the era of AI, at least. When we are discussing about the core of an AI system, we are discussing about two critical parts. The key components of the components that an AI system should have, and we should be addressing the real-time processing scalability of that part. When we say about key components, we're discussing about, at least in the context we're discussing, of course, we're discussing about data infrastructure and the engineering part of how an AI model or an AI application is served to the users. That particular task or subset of tools and components that an AI system has relies almost entirely in data engineering. Real-time processing, again, a very important part of AI, and it's very dependent on how the data are managed and how the data are fed to the AI systems, because we need to have systems that can give us access to real-time data, process data, correct data, robust data, etc. And of course, scalable. Right? The application should be scalable. Those two parts, those two sections of parts at least, essentially is what is data engineering alive for the, actually data engineering has been the most sexy job I've taken for the past 1 year and a half, trapping down data scientists. So, yeah, not that I am a data engineer, but anyway. Now, let's see a real-world scenario. As I said, this is something that we've been working on for the past 1 year and a half. In my mind, I've been working for that for the better part of the last 5 years, 6 years. But in the company I'm working on, it's 1 year and a half. Essentially, what this is, it's an integration of data engineering tools that gives us the ability to, first and foremost, distribute the load of the data needed, let's say, for an AI system to work on. Yeah. And yeah, let's start. Where should I start? So, of course, we will be using, in that particular case scenario, in that particular case, of course, we will be using, it's highly desirable to use tools that are already in place from any provider, like Docker, Airflow, Kubernetes, etc. The important one, which I will get out in a little bit, is the AI integrator. And we will discuss about what it is. The important thing when we are discussing about data engineering, AI, data science generally is the processing of the data and how this data can be fed to any system, any data system, in the context of what we're discussing now, it's for an AI system, an LM or whatever, is handling and processing the new data as they come in, right? So the first problem that we were called for to answer, at least, it's how, one piece of information in case you don't know here, is that every year that passes, we are producing 95% of the data that are available worldwide. And the rest 5% are generated since the conception of internet. So what that means essentially is that as we are proceeding into the future, of course, or in the present, we are building more and more data. We are transitioning not so easily to the era of big data, and we need systems that can handle big data in the most optimal manner. And this application, this scenario, ensures that by handling only new data as they come in. Right? Of course, it's a concept, right? When we're discussing about big data, I'm not referring to the data of the World Wide Web, I'm referring to some data from a business or whatever. The logic here is that, as I said, we will be ingesting only the new data from the engineering perspective. We will be monitoring everything, and we will have a layer, a container, something, whatever, that handles that sourcing of data into the application, the feed of the data into the application. We have two main streams. It's the data from ingestion layer to the bronze bucket, and the data from facilitator, again, to the bronze bucket. The reason we have two separate streams, two separate pipelines, is that we need to ensure that the standardization of the data needs to be happening before the data are available to the system, to the AI, in the context of what we're discussing about now, right? When they come into the data lake, which is the bronze bucket, we will be processing them, making them be the way we want them to be, and then using Docker, Airflow, Kubernetes, we will distribute the load to the whole cluster, of course, and then it will proceed to Spark, Kafka, or whatever. As I said, the most important thing of everything here is the AI integrator. The AI integrator, it's an idea, concept, thought concept, whatever, that essentially it gives us the ability to provide agnostically the configurations and the data that the application is using and the application needs in order to work automatically. What I mean about that is that imagine that you are interacting with ChatGPT and you want to build a pipeline. What essentially you will be doing is that you will be logging in ChatGPT or any AI tool, any LLM. You will be logging in that tool, you will be asking what you want to do, and you will be then requesting to give you back either the code or the logic that you need to develop the code. I will not go into the specifics of how that works. I will only say that in order for that to work, it needs two main things. It needs embedding model and a vector database. This combination of the embedding model from prompt to embedding and from embedding to a vector database, it's not the most, but one of the most critical parts of an AI, of an LLM, because it needs the biggest time to work. Right? So the question we need to answer here is how we can make that work in a better, in the optimal format, in a faster, better, whatever. And the idea behind that is that we will split essentially the vector database, the embedding model, into smaller chunks, smaller tools, let's say, in order to help the application to decide the application itself, the process that it needs to run in order to develop the best prompt, for starters at least. How you can do that? The easy answer is you can't. But if you devise a way using the engineering principles, tools, whatever, to split the embedding, the logic of the embedding model or the logic of the vertical of the vector database, and use that tools, those splitted tools, into creating the same logic that an embedding model or a vector database is doing, and as a final point, you give that particular tool, those particular tools, the logic that they need in order to create the prompts, then essentially you have finished the job and you have made the process more optimal or even more automated. And at the same time, you will be holding, instead of an agnostic application, which is an LLM, and it's based strictly on the training data that it used in order to give you the answers back, you have at the same time a deterministic model, which, not 100%, but in the majority of the possibilities, it will give you the correct answer back due to its deterministic nature. And when I say about deterministic nature, I'm talking about having a tool that essentially you will be pushing the configurations of any possible prompt that the LLM or an engineer or a business user or whoever needs in order to work. Right? So instead of having to train and retrain and retrain an LLM, by employing data engineering, you will be able to just use or save the configurations you may need in order to make the LLM work. Propagating the logic here is that the AI integrator, if you manage to have the configurations in place that support essentially the entire ecosystem of how essentially the prompting will happen in order to get the optimal results, if you extrapolate the logic, then essentially you can build the whole infrastructure. Of course, this is a high-level overview of that. You can extrapolate the logic to build everything in an automated manner. When I say everything, I'm referring, for example, to the ingestion layer. If I have multiple sources, the logic says that I don't know from starters how many sources I will potentially have. So instead of me as data engineer, instead of having to develop the algorithms that I need in order to ingest the data, I will have the AI integrator by simply using the configurations I have in place. And that's it, generally speaking. So you understand that the integration of data engineering AI, as stated before, is very critical. You can, by employing data engineering best practices instead of the art logic, etc., the best possible things from both worlds, from the deterministic nature of writing something ground up yourself with the agnostic nature of AI. And what you gain about that? The tangible impact of data engineering generally, it comes down, at least in my mind, in a single phrase: accelerating data pipelines. The acceleration of data pipelines is not referring only to the technical part of having a data pipeline work faster, better, etc., but also building the data pipeline faster, supporting less and less the data pipeline, and have the AI integrator supporting itself in an automated manner the data pipeline. In that way, again, you are reaching a point where you have the, I will say this again and again because it's the very essence of integrated data engineering, proper data engineering into the LLM, having the best possible things from deterministic and agnostic. Right? It's not only in the data engineering. The data engineering it's not only in the back end of everything. It's both in preparation, in analytics, in front end, everywhere. By having better, faster, either support or development of everything related to the AI ecosystem, you have something better, right? What is the true power of AI? You can ask 10 different people. Potentially, you can get 10 different answers. But in my mind, the true power of AI is not the way that it gives you answers, the way that it simplifies your day-to-day work or on anything. The true power of AI is understanding that it's not for everything, right? The AI is like imagination, which is the single most important thing, I would say, of humans and human creativity. You can't have this one here if you don't imagine what you want to do, right? You can, of course, say to the AI, to the LLM, that I want you to build for me, let's say something very simple. I want you to build me the bronze bucket with that structure, with that configuration, whatever, but you can't have the AI understand itself what you want to, where you want to be in 5 years, in X amount of time, in order to build everything on that manner. So, as I said, the true power of AI is understanding that it lacks imagination. The innovation part and the problem-solving part of AI is coming from humans, right? Of course. And that's why we have the second point, which is the human element in AI, which essentially highlights the importance of human creativity, imagination, complementing everything, and essentially boosting the use of AI on a day-to-day basis. Yeah, that's it. Where that comes to, at least. The efficiency of AI by employing, as stated before, best practices on data engineering, essentially it comes down to how you want to develop something in the manner of where you want, as I said, where you're going to be in X amount of time. And this is something that AI can't do due to the non-deterministic nature. Human oversight, human creativity, human maintenance from a human whatever on the AI system is very critical. And by exploring, utilizing, and developing state-of-the-art engineering tasks or pipelines, you are ensuring that. Where I see the future of AI and data engineering going is the relationship between, I will go a little bit more generic here, the relationship between data and AI, it will continue to evolve, of course. You will not be able to work in some amount of time, I'm not sure about how much, hopefully it's after I die. You will not be able to work on data without having to use AI in any manner. And the dynamic interplay between AI and data, and more specifically data engineers, will be bigger and bigger. Real-world impact. Turning our focus generally on maximizing efficiency, it's about precision, advancement, and robustness. Actually, those are the 3 key areas that we need to focus on if we want to build better and better either data engineering, the data engineering field, progressive data engineering field, or AI systems. Optimizing neural development is the very essence of what we have been discussing, actually monologuing for the past 25 minutes. AI, we need to understand that AI is a tool. It is a game changer, of course, and enhances the efficiency of systems that we hold on a day-to-day basis, that we are using day-to-day basis. They are precise, but they also are predictable. So we need to make it be as agnostic as it can be in order not to confuse the systems we already have in place with the new system we want to work on. Leveraging the power of AI into the systems, in the essence, in the context of data engineering, it's pivotal for driving technological advancements. In the second point, in the leveraging AI for technological progress, here is what AI becomes the extension of any, for that matter, data professional. It augments his or her capabilities. It's magnifying the efforts that he or she has to do in order to get the required result, because essentially, as I said before, the agnostic nature of AI, it's what essentially gives the difficulty working on. In its essence, it's not that we are just working on AI, we're just using AI to develop everything. It's integrated into the very core of the things we're doing every day, the development process, the testing, whatever. In that way, we can push the boundaries on what's possible, maximize efficiency on everything, etc. The role in data engineering. We have heard a lot about it. If AI will take our jobs, at least for the software-related professionals, etc. But we have heard also if, for example, this scenario here, whether or not AI is killing creativity because for the past 6 months, if I'm not mistaken, maybe more, AI can create videos, very realistic videos, photos, whatever. The potential of utilizing this, the nature, the engines, the neural networks, essentially, behind any kind of AI, more particularly an LLM, assumes that certain engineering tasks are predefined, which, if I come to my original, one of my original points, that the data are growing exponentially, this becomes a problem, this becomes a headache, and you need, how can I say it, self-improving techniques, automated, right? And this is where data engineering comes in. The last point on this slide is that we should be embracing AI instead of saying that I will not be using AI on a day-to-day basis because I have heard that actually a lot. I know what I'm doing. I don't need an AI to tell me what I'm doing. This is not the case. AI is not, it should not tell you what to do. It should help you to do it faster in order to focus on the more important parts of your job, at least. As I'm saying here, in case you have seen Terminator, even if AI's name is T-1000, right? You should not be afraid of AI. Future in data engineering and AI. As I said before, data engineering will be more and more combined, intertwined, and dependent on AI because the agnostic/deterministic nature of data engineering, because it holds both things at the same time, peculiar it is, but anyway, we should be focusing on more innovative engineering projects and practices instead of focusing on the standard keys of data engineering, which is, I would say, a little bit technicalities here, but like focusing on Spark, for example. Develop the best possible Spark cluster. It's no match for developing a Spark cluster that is empowered by AI, in the correct manner, of course. So the point here, at least in my mind, is that we should be focusing on the interconnection between AI and data engineering, because this is how the landscape of AI will be shaped in the future. And let us not forget, at least, that any kind of neural network, generally speaking, or AI project, is strictly dependent on the back-end data engineering and the back-end, generally speaking, infrastructure. This is not, I'm not saying all of this to focus on that we should not be anticipating changes and shifts in data engineering. On the contrary, we should be anticipating a lot of changes. For example, a very practical example I have, and I'm seeing more and more, is that last summer I was requested to develop an application, a data pipeline, whatever, for regulatory purposes in the company I'm working for. I developed the pipeline myself in 5 days without the use of AI. I developed the exact same pipeline with AI in 1 hour and a half. Of course, and this is before GPT-4. It was even, I think, before GPT 3.5. It was with GPT-3. I'm not saying that to say that I will be deprecated. I'm saying that to, again, augment the importance of AI in data engineering. Of course, as a small remark here, I knew what I was asking about AI. So if I got a wrong response, I told it that this is wrong, what you're telling, etc. Looking ahead. It's not so easy to say where we will be in 10 years' time or in 5 years' time or even tomorrow. The important thing here is that we should be helping shaping the narrative of data engineering and AI, generally speaking, right? I will close the presentation. I will go to the question section with repeating what I said before, that we should not be afraid of AI. The AI is augmenting the abilities that the data professional, more particularly data engineer, can potentially have. That's it. Thank you. I have this. Thank you. I have this barcode here. If you want to pose any questions, just scan the barcode, and I will be seeing the questions here, which actually I will be also showing here. Someone asked test.
Are you accepting only through this or every...
No. That also. Yeah, of course. Hello.
Okay. Thank you. Could you display the architecture diagram? I have some questions there for you.
Yeah.
The first slide.
This one here?
Yeah. So you separated the new data.
Yeah.
And all that is good. My question is, and you started your presentation with the amount of data we're processing and so on, how that's going to grow. My question is, a lot of that data, although it grows in volume.
Although, sorry?
Although it grows in volume
Okay.
all the time, and will do so in the future, there is a lot of that is repeated information of no new value. How, in a system like that, in a diagram like that, how will you tackle that? How would you decide what's valuable and what not?
Okay. With two ways, actually. This is about the standardization of the data before implementing any kind of logic. Sorry, let's... before implementing any kind of infrastructure in this diagram, whatever, essentially we will be deciding what's the standard data, what's the data will look like, the correct data will look like. This is about the two separate pipelines. If you see the two green lines between the ingestion layer and the facilitator to the bronze bucket. By using this, essentially you can achieve that any different than the standardized data, it will fall into the facilitator part of the architecture, which the facilitator essentially it has several processors inside, handled by a Kubernetes cluster or the load balancer from the load balancer, and it performs the processing, the required processing, in order to amend on those problems or whatever of the problematic data. This is the logic here. Again, the important thing is that the AI integrator, it will learn from the different cases of the problematic data as they come in. So anytime that a new problematic set of data comes in, the integrator will know it, and the next time, it will deploy a new processor that it will handle that problems. This is the logic.
Okay. Just one clarification. When you say problematic data, what exactly?
For example, I'm saying about missed data. If I have an API, for example, that hits the API every 30 seconds and a particular window fetches no data at all. This particular window, the logic waits that I have 30 seconds windows, right? If I don't have a field window, then this is problematic for me. So I need to deploy a processor that it will impute those data, for example. Or I can have null values in a non-null column, for example.
Okay.
I can have different formats. I can have more data that I can handle, or more data that I anticipate from the stream.
Okay. Thank you.
Thank you.
I would like to ask what kind of data do we expect the AI integrator to have as input? I guess that it's not going to study the whole bulk of the data. There has to be some kind of processing to send to it. I guess there should be some kind of process to extract in each of those inputs to extract useful information that the AI integrator will understand, or this is part of the AI integrator?
So just to confirm something, you're referring to what kind of sources I will potentially have?
No, I'm referring to the blue lines leading to the AI integrator. So,
okay. AI integrator to the ingestion layer or to the facilitator? Or to the data lake generally?
Leading from the bronze layer to the AI integrator.
Okay, so this is bidirectional, right? So what this exactly is that, as I said before, when you have a new set of problems, let's say that as they come into the pipeline, etc., the AI integrator learns from itself and deploys a new processor in order to remember that kind of problem in the future, right? Same exact logic is the bottom bidirectional arrow from the integrator to the data lake, which essentially you will be configuring deterministically the AI integrator about the things that you can probably or you can think of that you will want in the future. And these configurations through, again, I will go a little technical, through CI/CD, Terraform, Jenkins, whatever, it will be automatically be pushed through the data lake or to the facilitator or to the ingestion layer in order to automatically deploy new infrastructure. Of course, as code, generally speaking. But this is not the important part. The important part is that by simply configuring the configurations, if that makes sense, essentially by simply putting in place the configuration, which is something that you can't avoid doing manually, for starters at least, if you want to build a deterministic system on top of an AI system, you can't avoid the deterministic nature. The single one thing you need to do in order to support or develop or expand the whole architecture is to put the new configuration in the AI integrator. So the AI integrator, it will read them, understand them, and deploy the necessary services. The reason of the bottom arrow being bidirectional is it forwards and backward propagates, right? So it needs to understand the data that comes in the bronze bucket. And given that the bronze bucket holds the data that essentially it's the raw data that any application is using, I need to understand that the set of data that they came in from the ingestion or from the facilitator, it's not the correct data I'm using in the application, it's the bronze bucket. And that's why it's the bidirectional. And the reason of the dot there that essentially the Docker Kubernetes, Enterflow is giving to the AI integrator and from AI integrator is that essentially this is the part that I'm automating everything. So I'm using Airflow and Docker as an orchestrator to develop everything automatically and Kube to distribute. Thank you. If that's all, thank you very much.